algorithm. 1. Obtain the positive real number x. 2. Draw a line and mark a point A on it. 3. Mark point B on the line such that AB equals to x units. 4. From point B, mark a distance of 1 unit and mark the new point as C. 5. Find the midpoint of AC and mark the points as O. 6. Draw a circle with center O and radius OA. 7. Draw a line perpendicular to AC passing through B and intersecting the semicircle at D. Length BD is equal to root x. Justification. We have AB equals to x units and BC equals to 1 unit. Therefore, AC equals to x plus 1 units. Implies OA equals to OC equals to x plus 1 by 2 units. Implies OD equals to x plus 1 by 2 units. Now, OB equals to AB minus OA equals to x minus x plus 1 by 2 equals to x minus 1 by 2. Using Pythagoras theorem in triangle OBD, we have since OA equals to OC equals to OD. OD square equals to OB square plus BD square. Implies BD square equals to OD square minus OB square. Implies BD square equals to x plus 1 by 2 whole square minus x minus 1 by 2 whole square. BD equals to root x. Represent root of 9.3 on the number line. 1. Mark a line segment OB is equal to 9.3 on the number line. 2. Mark point C at the distance of 1 unit from B. 3. Find the midpoint of OC and mark it as point D. 4. Draw a perpendicular to line OC passing through point B. 6. Let it intersect the semicircle at E. 7. Taking B as center and BE as radius, draw an arc intersecting number line at F. 8. BF is root 9.3. 9. Draw a new number line on the same size as that of previous. 10. Take a compass taking B at the pointed end and F at the pencil end. Draw an arc on the new number line. 11. Mark point where the arc intersects, say X. 12. OX equals to root 9.3. Similarly, we can plot any irrational numbers. Summary.